All right, welcome back. This is at THS Mr. Jones with chapter 1.6, Polynomial and Rational Inequality. Okay, we are going to start with what is a polynomial inequality? Okay, so we know what a polynomial is. A polynomial is just a series of terms with variables in it. So, for example, we've been working a lot with quadratics, okay, and usually they equal 0. Well, with an inequality, we change that equal sign to something like that. So in chapter 5, we talked about linear inequalities, and in chapter 1.6, we're actually going to talk about quadratic and other polynomial inequalities. Okay, so how might I solve something like this? Well, let's look at what this means graphically. So if I graph this, actually let me graph this on a calculator. So if I graph this polynomial, so this is really saying I want to know when is this polynomial less than or equal to 0. So we have x squared plus x minus 2 graph. So I want to know when is this graph below 0, which means when is it below this x-axis. So actually my solution is this interval right here. So there is a range of values where this polynomial is less than 0. And now we're going to talk about the steps and how do I figure out what that range is, other than looking at the graph and guessing. You may guess that this is 1 to -2, that range. Okay, so let's discuss the steps. Number 1, you're going to get it into standard form. That basically means set it to 0. Okay, get everything on one side. Number 2, you're going to find the zeros. Okay, meaning you're going to factor this out and you're going to figure out what does x equal. Okay. Number 3, you're going to plot zeros on number line. Now, when you do this, you will use an open or closed circle. Okay, that will depend on what this says right here. So in this case, I'm going to use a closed circle because it was equal to. If it was just less than or greater than, we would leave an open circle. Step 4, you are going to Step 4 is you're going to test points in each interval. Okay, so you will have a number line. If we go back up to this one, okay, you will have a number line. Let's just factor this out here. X factors of 2, that's subtract a 1, that's 2 and 1, signs are different, the big one is positive, that's n equals 0. So in this case, x is -2 and 1. So you'll have a number line here. Here's 0. Okay, and you'll have a -2 with a closed circle. You'll have 1 with a closed circle. Okay, so now what this does is this splits my number line into 3 intervals. Okay, and what I want to do is I want to take a number in each one of these intervals and test it in the original equation right here. So you may pick -10, 0, and 10. Those are numbers in each interval. You will plug it in to see which one truly works. Okay, for example, if I plug in -10, that's -10 squared, which is 100, minus 10 minus 2. Well, 100 minus 10 is 90, minus 2 is 88, which is not less than 0, so that is false. So you'll go through and check each one, and your solution, this is step 5. Step 5, solution or solutions are the true intervals or interval. Okay, so in this case, if we tested this all out, we'd get true and a false there. Okay, so my answer would be bracket -2 comma 1 with a bracket because I had to close circle. So that would be your solution. Okay, so that's polynomial inequalities. Let's read our first video question here. Question number 1 is, how do I graph domain restrictions? Okay, and let's do question number 3 as well. So let's skip question 2. Number 3 is, how do I find solutions to rational inequalities? Okay, so that's going to lead me into what are rational inequalities? Well, remember, rational just means fraction. Okay, so I have a fractional inequality here. So it'll be something like this. Let's say x minus 3, x squared minus 4 greater than or equal to 0. Okay, I have a rational portion over here, rational expression, meaning x is in my denominator, okay, and x is in my numerator, and then I have my inequality sign over here. Okay, so again, if I were to graph this, I want to know, when is this graph bigger than 0 or above the x-axis? Okay, so if you see it, here's below, okay, and this area is above, and then this looks like all below. So I need to know, how do I find this range right here algebraically? Graphically, we can just look here and see where it is. Looks like it might be between -2 and 2, but algebraically we'll find the exact answers. Okay, so if we look at some steps to solve here. Okay, step number 1, okay, is to get everything on one side. Okay, you have to have 0 on one side, on the other side of your inequality here. Step 2 is to make one fraction. Okay, so like this here, I have one fraction, and that is what I want. Okay, if I have to move something to the other side, we're going to have to, find a common denominator and get it onto one fraction. Number 3 is to factor the numerator and the denominator. Step 4, you will list your excluded values or your domain restrictions. And remember, the domain restrictions come from the denominator here. So if I factor this out, okay, the top's factored, the bottom is x plus 2, x minus 2. So x cannot be -2 and 2. Okay. Step 5, list zeros from the numerator from the top. Okay, so you're actually going to factor this and figure out the zeros of each one of this. So here, actually, x equals 3 from the top. Step 6, plot zeros and restrictions on number line. Now, with this, okay, let's just go back up here and do this problem. Here's my number line. Okay, here's 0. -2 has an open circle because I cannot choose -2. +2 also has an open circle. And -3 is going to have a closed circle because it was equal to. So I actually can choose that. I cannot choose these because they were on the bottom and they can't equal 0. Okay? So a closed circle at 3. Now, this kind of repeats from the polynomial ones. So you plotted it on your number line. Number 7 is test points. Okay, so you're going to pick, what do we mean by test points? You're going to pick a number in each one of these windows. So in this case, I have 4 windows. Okay, so I might pick 0, I might pick -10, I might pick, well, I have to maybe pick 2.5 there, and I might pick 5 over there. Okay, so you're going to take each one of these points and test it into the original problem. Okay, and when you test those, you're going to get false here, true there, false there, true there. Now, not always does it go every other one. Okay, it's not going to do that all the time. Okay, sometimes you may have a false, true, true, false, or something like that. There could be 2 trues beside each other. And step 8, you're going to write a solution as interval. Okay, now in 1.5 we talked about unions. So here I'm going to need a union because I have 2 answers here, or I have 2 regions that I want the answer of both of them. Okay, so I'm going to have a parenthesis because of the open circle, -2, comma 2, parenthesis, union. So I want all the numbers in this one, and I want all the numbers from 3 to positive infinity. Okay, so my solutions are in here, but they're also here to infinity. Okay, so this is writing it as an interval. Okay, so we had question 1 and question 3. Question 2 is, what do we mean by test points? Okay, what does that mean, test points? Okay, this is it for 1.6. Here are your suggested problems. So we got starting on page 159. Okay, there's some suggested problems there. Go ahead and give them a look and maybe see what you need some help on. Again, they're all odd problems, so you do have answers in the back of your book. Number 73, I want us to be looking at these because these are mistake problems. Okay, so a lot of people will make these common mistakes, and I want you to find them in some problems before you actually make them. Okay, so you may start with this problem and just read through the steps of how to solve it. Okay, if you need the lesson video for 1.6, I'll link right here in this box. Okay, if you're gone, or maybe you need some extra help and can't come in before after school, okay, look these lesson videos up. maybe I explain the examples just a little bit differently, and that may help you out. If not, I'm here before and after school. Just let me know if you need help. This is @THS Mr. Jones signing off.